In this lecture, we are going to discuss the topic limits. Limit of a function at a point. Consider the function f of x. If the value of the function f of x approximates the number L for x close to x naught, then we can say that f approaches to the limit L as x approaches to x naught. That means, suppose we have a function f of x and x naught be a point, then as x approaches to x naught, then f of x approximates to the value L, then we can say that f approaches to the limit L as x approaches to x naught. And in that case, we can return this as f of x approaches to L as x tends to x naught, or x approaches to x naught, or limit x tends to x naught f of x is equal to L. Okay, so in that case, actually, if we plot the curve, we have two axes. This is for x and this is for y. Y is equal to f of x. Okay, so let this point be x naught. Okay, then if x approaches to x naught either from left or from right. Okay, that is x can be approaches to x naught either from left or approaches to right. Then if x approaches to x naught, then if f of x approaches to the number L, then we can say that f approaches to the limit L as x approaches to x naught, or this is a notation. Okay, for example, consider the function f of x equal to 2x square minus 7x plus 3 divided by x minus 3. Clearly, we know that this function is not defined at the point x equal to 3, because when x equal to 3 it will be something divided by 0, so it is not defined at x equal to 3. Now here we are going to find the limit of this function at the point x equal to 3 by numerically. Limit may be exist even though the function is not defined at that point. So if you take the x naught as 3 here, then we have, let 3 will be this point, this is 3. Now we are finding the values of this function at the points near 3. Okay, if we are trying to find the values of this function at the points x which are right side to the 3, we will get this. That is, at the point x equal to 3.5, we have the value 2 into 3.5 whole square minus 7 into 3.5 plus 3 divided by x minus 3.5. So the answer will be 6. So when x equal to 3.5, we have the value 6 for f of x. So 3.5 will be like this. This is the point 3.5. Then we are finding the value at the point 3.1. So it will be here, and the value is 5.2 at the point 3.01. So we are decreasing the distance between these points. First we take the distance delta x as 0.5, then we decreased this to 0.1, that is, this is the 3.1. Now we are decreasing this, delta x, we are approaching to we are trying to approach this delta x tends to 0. So decreasing this length, we can use the next point 3.01. When we apply this point here, we get the value 5.02, and decreasing again to 3.0001, we get the value 5.0002, and again decreasing we get for the value of x 3.000001, we get the value 5.000, etc. We know when x reaches 3, it will not be defined. It is not defined at x equal to 3. So we are taking the values near to x. So that is, we are letting x approaches to 3 from left side, right side. Okay. So as x approaches to 3, that is approaching to 3, we have f of x approaching to 5. As x approaches to 3 from right side, f of x approaches to approaching to 5. In a similar way, if we are finding the values of f of x for the values x left side to 3, we will get this. That is, first we take the x is equal to 2.5. So 2.5 will be left side of this 3. It will be like here 2.5. The corresponding value of f of x is 4. If you choose x equal to 2.9, that is we are decreasing, as 2.9 will be here. Okay, so that is we are decreasing this length. Okay, so at that point we get the function value is 4.8. Then we are increasing again, that is 2.99. It will be here, somewhat here. So the corresponding value will be 4.98, and then 2.9999, we get the value of f of x is 4.9998. And if you take the value of x as 2.999999, then we get the value of f of x is 4.999998. Here also we can see that as x approaches to 3, this is going to 3 from left. As x approaches to 3 from left, the f of x approaches to 5. Here also it is approaches to 5. Clear? So from these two tables we can see that if x approaches to 3 either from right or from left, then f of x approaches to 5. In each case f of x approaches to 5. So in that case, so we can conclude that uh, f of x approaches to 5 uh, if x approaches to 3, or we can say that limit tends to 3 f of x equal to 5. Okay, so this is numerical method for finding the limit, but it will be not convenient to apply in all the cases, because we have to find the values of these points, etc. Okay, it is not convenient. Okay, another way of finding this limit is nothing but we have our function f of x is equal to 2x square minus 7x plus 3 divided by x minus 3. So this can be the function in the numerator can be factorized like this: 2x minus 1 into x minus 3 divided by x minus 3. So uh, if x is not equal to 3, that is if x is not the point 3, then we can divide this, that is it will not be 0, so we can divide this and we'll get 2x minus 1. That is, this function f of x is equal to 2x minus 1 if x is not equal to 3. So we are finding the value of the limit, that is as x approaches to 3. We are not finding the value of the function at x equal to 3. We are just finding the approximate value of f of x as x approaches to 3. So that means we are not taking the point x equal to 3. So if x is not equal to 3, we can divide this. So this f of x is equal to this function if x is not equal to 3. In that case, if x is not equal to 3, that is x approaches to 3 implies f of x equal to 2x minus 1 approaches to 2. This approaches to 2 into 3 minus 1, that is 5. So as x approaches to 3, f of x approaches to 5. Okay, this is the another method of finding this limit. This will be more convenient method. Okay, now we have some notes. First note is the quantity limit extends to x naught f of x depends upon the values of f of x for x near x naught, but not for the x equal to x naught. That means this limit does not depends on the value of f of x at the point x naught. That means this limit does not depends on the point f of x naught. This limit depends only depends on the points for x points of f of x near for x near x naught. Okay, that is, if this is x naught, then the limit does not depends on the points at the the value of f of x at the point x naught. It depends only on the nearby points of this x naught. Okay, that is an important note. Second note is, as we know, the limit of this limit is actually, as x approaches to x naught, f of x approaches to a unique number L, then we can say that this limit f of x, limit extends to x naught, f of x is equal to L. If x gets nearer and nearer to x naught, that is, if x approaches to x naught, the values of f of x might not approach at any fixed number. That means, in that case, we can say that f of x has no limit as x tends to x naught, or limit x tends to x naught f of x does not exist. Okay, that is, if x approaches to x naught, then if f of x approaches to a unique number L, then we can say that the limit of f of x is L as x tends to x naught. If x approaches to x naught, then f of x is not approaching to a fixed number. If f of x is not approaching to a fixed number, then we can say that the limit does not exist. Okay. Now, next one is, in determining limit extends to x naught f of x, we must consider the values of x on both sides of x naught. We already discussed that. We have to consider the both sides of the points at x naught. Okay. Now we can do a problem. Reading the graph in this figure, find limit t tends to b g of t if it exists for b equal to 1, 2, 3, 4 and 5. Okay, so that is, here we are given a function g of t, y equal to g of t, and it is given by this graph. This is like this, and here we have this dark line is the graph, and this is the point in the graph. So here we are given that a small circle means that the indicated point does not belongs to the graph. That means here we can find a small circle here. We can find a small circle here. That means uh, it is not, this point is not belong to the graph. Okay, so here from this graph we can say that, we can see that this limit, the function is defined at these points. Okay, this is the function value. That means this is the function value and is defined at, what about 2? At the point 2, the function value is this, that is 1.5. Okay, so this is not the value, this is not the value, but this is the value at x equal to 2. Okay, that is what is this small circle means. And at the x equal to 3, the function value is this, that means this is 0.5, not this, not this is the point 0.5, etc. And at the point 4, it is not the point, that means at the point 4 it is not defined, the function is not defined. Clear? Okay, and at the point 5, here also the function is not defined, because there is no point in this graph here. So at the point 5 also function is not defined. Okay, now we have to find the limit t tends to b g of t, where b equal to 1, 2, 3, 4, 5. That is, we have to find first 5 limits. First one is limit t tends to 1 g of t. Second one is limit t tends to 2 g of t, etc. Okay, so if you take the first one, b equal to 1, what about the limit? That means this is the point t equal to 1. That means as t tends to 1, that means when t equal to, the first case is b equal to 1, so we have to check whether this limit t tends to 1 g of t exists or not. Okay, if it exists, we need to find the value of that limit. So at t equal to 1, when we trying to find the values of g of t as t approaches to 1 from left and right. From left, if we are trying to approach x, that is t to 1 from left, then f of x will be like this. Okay, it will be, this will be that point. Okay, that means 0.5. Okay, so this is not f of x, this g of t will be 0.5, and as t approaches to 1 from right, then also this curve is coming from this to this point. So this is the point, that is the limit. At limit t tends to 1, g of t will be 0.5. Clear? From this uh, figure we can see that. Also, then what about b equal to 2? B equal to 2 means limit t tends to 2, g of t. So we are trying to actually to at the point 2 the function is defined, because here the here at the point t equal to 1 we already know from this that g of 1 is equal to 1 itself. Okay, g of 1 is 1, it is defined, the function is defined at the point 1 and the value is 0.5, and the limit is also 0.5. Okay, in the second case b equal to 2, what about g of 2? G of 2 is defined, that is g is defined at the point 2, that is g of 2 is nothing but this point, that is 1.5. Clear? It's 1.5. So g of t is 1.5. Now what about the limit? Limit t tends to 2, g of t. As t tends to 2, we have the curve approaches to this point. This point is 1, right? This is 0.5, this is 1, so this point is 1, and from t approaches to 2 from right, then also we can see that this approaches to this point, this point is 1. So this as t tends to 2, g of t tends to 1, but this is not the point g of 2. Okay, here the limit exists, and that limit is not equal to the functional value, but in the first case the limit exists and it is equal to the, yeah, it is not, it was g of 1 is equal to 0.5, so it is wrong, so g is 0.5. Okay, in the first case the limit exists and it is equal to the functional value at that point. Okay, in the second case the limit exists but it is not equal to the functional value. Okay, now what about the third case? Third case is t equal to 3. When t equal to 3, that is b equal to 3 implies g of 3 is defined or not. G of 3 is defined and the value is this, that is 0.5. Okay, this is the point, that is 0.5 is the g of 3. Now what about the limit? Limit t tends to 3, g of t is equal to, as we trying to as t approaches to 3 from left, as t approaches to 3 from left, the functional value approaches to 0.5, and as 3 approaches to right, 3 from right, then function value approaches to this point, so this is 1. So this limit does not exist. Okay, because as t approaches to 3 from left, we have g of t approaches to 0.5, and as t approaches to 3 from right, we have g of t approaches to the point 1. Okay, so g of t not approaching to a fixed number as t approaches to 3, so this limit does not exist. Clear? That is the case 3. Then now b equal to 4. B equal to 4 means we have from this figure we have g of 4 is not defined. Okay, because from this figure we can see that this is a circle here, so g of 4 is not defined. But what about the limit? As t approaches to 4 from left, we can see that this function, the curve approaches to this point is 1. So from as t approaches to 4 from left, this g of t approaches to 1, and t approaches to, as t approaches to 4 from right, you can see that the curve approaches to the same point. So we can see that we can say that the limit t approaches to 4, g of t is equal to this point, which is equal to 1. From this case, we can see that the function is not defined at the point 4, but the limit exists at that point. Even though the function is not defined at the point, then there may be the limit exists at the same point. Okay, so that is the case 4. Now, next is b equal to 5. That is the point 5, t equal to 5 here. So, what about g of 5? G of 5 is not defined. From the graph, we can see that it is not defined here. So, what about the limit? For the limit t tends to 4 g of t. This is not 4, this is 5. G of t is, from the figure we can see that as t approaches to 5 from left, g of t is grows larger and larger to infinity, and as t approaches to 5 from right, then also g of t grows larger and larger, and it does not approach any limit. So limit t tends to 5, g of t does not exist. Okay,